Okay, hi. So here is a little video on solving inequalities. And as you can see, we have a rather complex inequality picture. -4 times -4 plus x is greater than 56. So first we're going to solve it, and then we're going to graph it on the number line. So here we go. So to solve it, we can do this two ways. The first way involves using the distributive property, so we need to distribute the 4 to both the terms inside the parentheses. So -4 times -4 is positive 16, and -4 times x results in minus 4x, and it's still greater than 56. So we can get rid of the 16 here. We've got a positive 16, so we can subtract 16 from both sides. So it's just like solving equations. What you do to one side, you do to the other side. So the 16s cancel out, and we're left with -4x. And on this side, 56 minus 16 is 40. Okay? Now, we're going to get the x to stand alone, and so what we want is to divide this by -4, and we're going to divide this by -4 over here. Now, when we divide by -4, we need to change the sign. In order to have a set of solutions that is correct, we need to change the sign. So -4x divided by -4 is x, and 40 divided by -4 is -10. So if we want to plot this on the number line, we're going to target -10, and x has to be less than -10. So we're going to draw our arrow this way. Okay? And we're not going to fill in the boundary point at -10, because if we take a look right here, x has to be less than -10. It cannot be -10. It can be any number less than -10, including 10.1, 10.2, and so on and so forth, but it can't actually be -10. So we're not going to color it in. Now, I mentioned that there were two ways to solve this inequality, so let's take a look over here. The first way involved using the distributive property. The second doesn't. So what we can do is we can divide each side by -4. So these -4s are going to cancel out, which is going to leave us simply with -4 plus x, and -56 divided by -4 is -14. However, important to remember here that because we have divided by a negative number, we need to change our inequality symbol to its opposite. So now we can just solve as normal. We've got a -4, so we're going to add 4 to each side, and that's going to give us x is less than -10. Okay, so either way you do it, you're going to get the same answer, which makes sense. Now, if we did not switch the inequality, if we kept x is greater than -10, we would be saying that any number here would make the inequality true. So let's see how that works. Let's pick a random number. Let's say we're going to pick -4. So if I put a -4 here where x is, I'm going to end up with -4 plus -4, which is -8. I'm going to multiply it by the -4 that's here, which is positive 32. And I'm going to end up with a statement that positive 32 is greater than 56, which is not true. So we can't use that number. And that will, in fact, happen with any of these numbers in the green bracket and any further to the right. So we change the operation to a less than, because it's actually these values, not including -10, that make it correct. So let's try it with -11. If I put a -11 here with the x, let's just think this through. -11 plus -4 is -15. -15 times -4 is positive 60, and positive 60 is greater than 56. So these numbers make the inequality true. So maybe we can try another one just to make sure that we know what we're doing. So let's try a solution or a question that has division in it. So x divided by -6 minus 8 is less than or equal to -12. So first of all, I'm going to target my -8. So I'm going to add 8 to each side. Okay, these cancel out, and I'm still left with x over or divided by -6 is less than or equal to -12 plus 8 is -4. So at this point, I need to isolate my variable. I'm dividing my variable by -6, so I'm going to go ahead and multiply it by -6. But what I do to one side, I'm going to do to the other side, multiply by -6 here. So if I take x, divide it by -6, and multiply it by -6, I'm going to have x here. -4 times -6 is 24, and my sign is going to change. So now I need to graph this. So I'm going to go over here and find out where 24 is. And so x can be, x can be 24 because it's 24 greater than or equal to 24. So being equal to 24 means that it can be 24. So I'm going to fill it in, and any number greater than 24 will work. Right there. Okay? Now, again, by changing the sign, we're saying that, hang on, we're changing it from less than and equal to greater than and equal to, and it's saying that, hey, these numbers are not going to work. It's the numbers that are on this side that are going to work. Okay? So let's just test this out. Let's grab a random number here. Let's say we're going to use 20. And we're going to go back up here and we're going to say, actually, let's go with 18. If I have 18 for x divided by -6, that's -3. And if I subtract 8 from that, -3 minus 8 is -11, and -11 is not less than, whoa, I think I just messed up here. Let's try this. Let me think this through again. 18 divided by -6 is -3, minus -8 is 11. Oh, yeah, I was right. -11 is not less than or equal to 12. It's actually greater than -12. Okay? So these numbers in the green won't work. If I take a number from the red, let's try 24 this time. 24 divided by -6 is -4, minus 8 is -12. Is -12 less than or equal to -12? Well, yes, because it's equal to. So that proves that the 24 would work. And in fact, any of the numbers in this red section would also work.